I'm Gabriele Sorrento, CEO and co-founder of Mindesk and head of global partnership of Vectron Technologies. I gave a keynote this morning about real-time technologies. And now I'm delighted to introduce our partner and computational designer, Arturo Tedeschi. He's a very, very talented artist who explored parametric. He was one of the pioneers of parametric architectures, and he's also the author of the parametric architecture book that is becoming one of the base textbook for any student who is approaching this technology. He worked for Zaha Hadid Architect before founding his own design company. So today we're gonna show the process of creation of a 3D car using Rhino and Mindesk technologies. As I mentioned earlier, Mindesk is a real-time platform that connects CAD software like Rhinoceros, but also Grasshopper and Kite to new technologies like AR, virtual reality, and graphic engines like Unreal Engine. But without further ado, I will leave the word to Arturo Tedeschi, who will present an original electric car concept called Iris.
Thank you so much, Gabriele. Can you hear me properly, first of all?
Yes, I do.
Okay, perfect. Thank you so much for the introduction. Hi, everyone. It's a great pleasure to be here with you today and presenting this concept. My name is Arturo Tedeschi, as Gabriele mentioned before. I'm a computational design expert, and I'm the founder of AT, which is an office which work for all industries facing, let's say, challenges connected to geometric complexity. Actually, we are not strictly, of course, car designers, and we are not involved in tool development. So for us, this project and this concept was, with this concept, actually, we explore the idea of a design journey, actually, from a first sketch that we done by hand, actually, through virtual reality, through real-time rendering. And there is an important thing behind that. We did everything in 5 working days. That's super important for me to tell, because since we are not car designers, using and by the use of advanced technologies, we had the opportunity to do this kind of design journey. Gabriele, you can also start the video if you can. Okay. So, well, the idea was to create two-seater electric car with a feminine look, actually. So we also try to create something that I defined a possible future car. So an advanced concept, but with the possibility in a way to design and to manufacture, to fabricate the car like today, tomorrow, in a way. So everything about the idea of something possible and advanced in the same time. As you can see now, there is an accelerated video about the first stage that was about the three-dimensional modeling of the car. We followed basically, we used Rhino in a, let's say, traditional way. Is and according to a bottom-up process. So we didn't created the general shape using, for example, a subdivision tool, but basically surface by surface, we developed the whole process. everything is NURB based. We played with concept like curve fairing, like curvature, continuity. Of course, we use the tools in Rhino, available in Rhino, in order to control all the mathematical features, like once again, according continuity and smoothness, but basically according to a traditional workflow, which is from, let's say, curves to final surfaces. In terms of design, you can see a kind of transition between hard and, let's say, smooth and hard edges, and in order to have, once again, a kind of feminine look to the car itself. Then we switch to the virtual reality realm, in a way, because we are, let's say, the grasshopper expert. So we are expert in creating algorithms in order to support the design creation. But in a way, sometimes it's very frustrating to jump from a platform to another one. So that's why we used Mindesk. That was critical, and it was an amazing tool for combining everything together. So we had the opportunity to explore the object in a three-dimensional way. One of the incredible feature that you can also see in the video right now, you can understand the scale of your building also with a simple proportion that you can read meanwhile you are playing with joysticks in virtual reality. And so you can combine in a way, in a very specific way, and you cannot find this kind of feature elsewhere, is the possibility to control the geometry, but also the algorithm, as you can see right now. That's absolutely, it's unbelievable. It's amazing for us that we like use and we play with Grasshopper scripts every day. And so in the same virtual reality environment, we have this kind of possibility to have a kind of canvas. And so was possible, as you can see right now, to control, to set parameters, and having a real-time um, three-dimensional output in Rhino, of course, but in the same like VR environment, as you can see here. And that's phenomenal, because you can really forget about the tools. In a way, you can forget about all the complexity that we deal with every day when we are dealing with geometric tools. But you are in your space, you are really focused on the output. As you can see also, you have a kind of double interaction, since our algorithm was in connection with Rhino geometries. We had the opportunity to both to control the algorithm itself in order to change parameters, for example, but also to interact with Rhino geometries. So once again, probably repeating myself, but in the same environment, you have the possibility to play simultaneously with the Grasshopper canvas and with Rhino geometries. And for us, as a like concept explorers, as a designer, was the idea of be focused on the geometry, on the final output, as you can see here. And once again, it's amazing the control of space, and in the same time the control of geometries. As you can see here, the possibility to interact with geometries, with curves that in turn they like feed the algorithm that controls, for example, in this case, this kind of shading system that we parametrically defined as an algorithm in Grasshopper. But as you can see, you can play with the position dimension of shading system also when you are inside the car, in order to understand how it will look like when you are inside the car itself. So it's a kind of shifting in the way we design objects, and was absolutely incredible for us. And I want to point out again that everything was created in 5 working days, and absolutely was not possible like according to and relying on traditional tools. The scaling is also another absolutely important like tool in order to control the shape. Gabriele, you can probably, you want to mention something about the interaction with
Yes.
with
So this morning, one of the panelists mentioned patterns, and again, we are presenting a pattern. So we feel like we are following the wave. Here, we can see also the use of Logitech pen that Mindesk is fully integrated with. That can provide the most accurate and precise input possible. Indeed, we are using the pen here to take measures inside the car and also to draw sketches, like for example, this alternative bracing system for the wheel. It's very super intuitive. It's just like having a pen that can draw in leave ink in the space, and yeah, you can make annotation. Like for example, here we wanted to establish a limit that the pattern should never cross, and so we can just draw a line. This line is stored in Rhino as a point line. So then you, as an artist, as a designer, can then edit the pattern, the curve, in order to not cross that line. And this is just like one of the example where interacting with the model in an immersive 3D space becomes fundamental, useful, not only from an aesthetic standpoint, but also from a technical standpoint, because being immersed allows you for checking the ergonomy of each space, of each component, and being 100% sure of what you're doing.
Yeah, and another super important feature that Mindesk allows users to do is like this kind of amazing connection with Unreal Engine. You probably know that Unreal is a video game actually engine allowing you to simulate physical behavior, also to define materials, of course. And you know how frustrating usually is to control how your vehicle looks like when you are defining something. In general, the renderization within the real-time renderization within three-dimensional software, also in Rhino, is amazing. It's very good, but it doesn't reach the level, the real life level. So Mindesk allowed us to have this kind of direct real-time connection between Rhinoceros and Unreal Engine. So we have the possibility, as you can see here, to define materials like let's say automotive materials, car painting, but also lights, as you can see right now. Materials, they are created in a procedural way inside Unreal, so using a like node-based interface. And so it was amazing to directly work, once again, as the screen is showing right now, playing with the geometry in Grasshopper, for example, controlling it in Grasshopper. Basically, we had the opportunity, the possibility to change, and we are still focused on the shading system, to change the geometry using the algorithm, or in Rhino if you want, and applying directly the material like this. So this is something absolutely novel, at least for us. So the possibility of having a kind of 360 control in shape generation, shape geometry control, and also controlling in the same time, managing in the same time the physical behavior in a way, but how the concept looks like with real life material. And everything combined, of course, with the virtual reality environment gives a kind of really a kind of look which is totally immersive. And but we appreciated not only the shape exploration, but also the control and the possibility, a possibility that is not available in other systems. And since I think that algorithmic modeling will become increasingly important, the idea of having a platform able, like Mindesk, able to create this kind of connection is absolutely critical, and we get a lot of benefits from that. Once again, I think it's not possible to reach this kind of let's say design level if you don't have the right tools allowing you to explore all these things. As you can see now, here there is modification of curves in Rhino that creates modification in real time in the Unreal model with the material that interacts in real time.
Arturo, the pattern you have designed on the roofing of this car,
Yeah,
it's really attractive and sinuous,
yeah.
if you concede me that. Um, how was the experience of changing the shape and experiencing that outcome in real life? How this affected your workflow?
Yeah, that's a very important question because I was mentioning that in general you create three-dimensional objects and pattern complexity sometimes, but in general you have a kind of flat output because you have the output from Grasshopper and Rhino is usually not only not attractive but is not realistic. So sometimes it is good on the paper, let's say on the digital paper, but you don't have a real 360 look. You cannot really understand how it will look like when you apply the material. Also because for the pattern itself, also because we have the opportunity to simulate and to understand the pattern itself from the inside, and not only on a mathematical surface like usually we do. So it's very interesting that you can like manipulate the geometric complexity when you are inside the car. And that, for example, was super important in order to explore, let's say, 3-4 alternatives that we selected for our concepts. And actually, they were not the ones that we selected, let's say, before the pattern was applied in the car in real time on a real engine.
Not to mention the fact that here the pattern is also LED luminescent, so there is
Mm-hmm.
also lighting
Yeah, yeah,
involved
yeah.
besides the materials.
Absolutely, something that once again, the Grasshopper and Rhino environment, they basically have they flatten everything. You don't have you need to do a kind of effort in terms of imagination when you are just in Rhino. This kind of connection was super important for us to understand the real impact, and it's not possible if you cannot control in the same time geometry but also material, and in this case also the lightness effect, also the reflection. For example, we realized that some reflection was not good, for example, at the first time.
And this is the outstanding final result. I'm really glad that you work with us on this concept.
It was not possible without your fantastic tool.
Okay, well, thank you very much, Arturo. Um,
Thanks to
be,
you, great pleasure.
I would like to show this other module where Mindesk is connecting Rhino to Unreal, and then we launch Kite. So because Kite is based on Rhino, uh, it just works immediately in real time to the point where even the camera synchronization is affecting the Unreal in real time. And as you uh, select and edit this surface, this is immediately showing the final result in Unreal with material applied. In this case, is a smoke glass on the roof of this car. Moving forward, yeah, this is another editing process until we reach the perfect fit with the underlying model. The other aspect is, of course, virtual reality. So we tested Kite in virtual reality, and again, it worked pretty well, meaning that you can explore the model and have a Class A surface in Kite. As you see, when I select the control points, they're activating in Kite in real time. So even selection is bidirectional, and editing the surface will immediately affect the Kite surface. I didn't did this here, but is bidirectional. So even working on Kite would affect the VR world. So this enables the workflow that you were mentioning earlier, where someone worked from the CAD, and then this is happening in VR. And then once we integrate this with Varjo, this could happen on a single machine where you have virtual monitors and the virtual model on site.
Hey, Gabriele, how fast did you this? You got Kite last week, and it works now.
Well,
Incredible.
a lot of credit should go to T-System, who developed a very intelligent software architecture that is based on Rhino. So uh, it was not necessarily a huge effort from our side to make this work, because even Mindesk has a very flexible software architecture. So when we put all together, there were no bugs, no flaws. Everything was pretty stable, and even the connection to Unreal was pretty straightforward. And this is the demonstration that when companies have a far-looking approach, and they do the things properly, and then we also reach a level of reliability that is not common, frankly speaking. Um, and this
Well
is
done.
this is the last point I want to touch today. So today we explore a journey from the early sketch to the render, but we can push this journey even farther to the car dealer and see uh, what we can do. So we exported the car into the FrameS platform, and in FrameS we have a super intuitive interface that anybody can use to explore the 3D model of the car, but also configure it. And this is ideal for dealing with the final customer, for example, at the car dealer point. And this is what we're looking forward to. So to cover the whole life cycle of a car, from the first scratch to the sale process. I mentioned earlier something that we are exploring is the possibility to empower the car configurator with not only with the possibility to personalize and customize the material, but pushing forward with the customization of geometry, like for example, replacing single parts inside the car model, or even customizing the geometry and the shape. Imagine if you could like change the shape of the rims in a parametric way, and then have a custom rim delivered from the car producer. This will be possibly something that is not possible today, but we could reach this level by integrating the Mindesk technology into car configurators like FrameS. This is an open discussion. I would like to receive your feedback on that as well.
Gabriele, where are you taking the materials from? Could we, for instance, add our internal materials to this library and use it in the dealership?
Yes, it's very likely that we can arrange this, because
Yeah. And
material today have a very standard definition. So we can definitely work on synchronizing these libraries into the FrameS.
And which materials are you using in right now here in your demo?
These are
From Unreal?
no. These are our custom material. FrameS
Oh,
is a software based on Unity.
okay.
Just to give you further information.